Hello everyone, myself Farzana Sultana Samia. I am a PhD student in computer science at Iowa State University. Today I will be talking about a model, mT5, which is a massively multilingual pre-trained text-to-text transformer. Let's begin with the background of this paper. There are some well-known models such as BART. Those are only in English language. But this is kind of limited 80% of the world population who does not speak in English. With this motivation, authors of this paper created a multilingual version of T5 model, which is mT5, and this mT5 model almost similar to mBART, and so on. mT5 model trained with a dataset named MC4, which is a multilingual variant of C4 dataset, and this dataset contains 101 languages, which is drawn from publicly common crawl web scrap. Next, state-of-the-art model before creating mT5 model. There are some state-of-the-art model such as mBART. This is a multilingual variant of BART model which is closely follows the BART recipe as possible. The next one is XLM. This is a cross-language model, and this model is an improved method for pre-training multilingual models. Another XLM version is XLMR, which is also an improved version of XLM, and this model is based on Roberta. The next is mBART. This is another multilingual version of BART model, and this model trained with a combination of span masking and sentence shuffling objectives. The last one is merge model. This is basically a model is a pre-trained sequence-to-sequence model learned with an unsupervised multilingual model. It is trained to reconstruct a document in one language by retrieving documents in other language. You can see in this table there are many multilingual version of models. Here is the mT5 model. The authors of this paper applied the encoder-decoder based architecture and the parameters starting from 300 million to 13 billion. And the dataset contains 101 language, and the data source scrap from publicly common crawl web scrap. The dataset name is MC4. Now moving on to the architecture and training of mT5 model. And the mT5 model closely follows the T5 model recipe. They are in their architecture, the fill in the blank and span corruption. Actually, what this is mean? Let's take an example. Thank you for inviting me to your party last week. Here, they have marked the phrase for inviting as X and marked last phrase as Y. And the model is expected to give the output of the phrase for inviting and last. This type of objective is called span masking. And this is almost like 15% of the text was corrupted during the training time. The authors of this paper used the encoder-decoder base architecture, and as we all know, if we have several layers of encoder and decoder model, this model will particularly have twice the number of parameters as compared to encoded on your decoder, and this will increase the computational cost of this particular model. In order to address this issue, the author of this paper shared the parameters, and they have proved that there is no performance degradation in this encoded training. Now moving on to the MC4 dataset. The MC4 dataset basically scrapped from publicly common crawl web scrap, and then the scrapping duration is 71 months. After that, they have applied one technique named CLD3 to identify over 100 languages, and these tools can detect the primary language. If the web page contains 70% or over the same language, then it will detect the primary language of these web pages. If the web page has below the 70% of the same languages, then it will remove those languages. After that, they have applied a line length filter. It is basically requires page to contain at least 3 lines of the text with 200 or more characters. After that, they have used some deduplication technique to filter out the repeated text in the corpus. The corpus contains 101 language. So we here, the author of this paper collected a huge number of datasets to train mT5 model. Now the mT5 model, as I told before, that mT5 model closely follows the recipe of T5 model. One of the main differences between T5 and mT5 model, however, they have used of gated exponential linear units, which is GGLU, nonlinearities activation function. Actually, this GGLU suited best for mT5 model, and they have given the better performance than standard glue function, which is applied in T5 model. After that, one of the most important aspects is sampling technique. And they have used this sampling technique for low resource and high resource language. The probability is inversely proportional to the square root of the number of available examples for a language. After that, they have increased the vocabulary size, which is 250,000 word pieces. After that, subword units, which is basically a fragments of words or sentences. The subword units are fragmented one word or sentence. By breaking words into subword unit, model can better handle when the model is out of vocabulary words. However, there is one drawback in these mT5 model is that the size of vocabulary also requires more memory and computational resources to train and use the model. Next, moving on to the mT5 model configuration. And basically, mT5 uses the same inverse square root learning rate as T5 model used during the pre-training, which can able to improve the stability and convergence speed. They haven't applied any dropout during the pre-training. The same self-supervised objective as T5 is used for pre-training with 15% of token masked and an average noise span length of 3. For fine-tuning, a constant learning rate of 0.001 and dropout rate of 0.1 are used for all tasks. A batch size of 2 to the power 17 is used for most tasks, with exception for Wiki and Year Zero Shot, where they have used 2 to the power 16 for small training size, and in XNLI, where they have used 2 to the power 20 for better performance. Checkpoints are saved every 200 steps, and the checkpoints with the highest performance on standard validation set specified by extreme is chosen for early stopping. Now moving on to the experiment conducted in this research paper. Actually, there are 6 experiments done to evaluate mT5 model, and which are all coming from extreme multilingual benchmark. Starting with the sentence pairing, they have done 2 experiments. First one is XNLI, which is cross-lingual natural language inference. In these models, main goal is to understand or predict the relationship between the sentences. Now, next one is PAUSEX, which is a parallel cross-lingual wikis. This model mainly identified if the sentence is paraphrased or not. The second part of the task is the name entity recognition, and this wiki and an annuar is used to evaluate the name entities such as person, organization, and location. The last part of the extreme benchmark is question answering experiments. The first one is squad cross-lingual question answering dataset. This benchmark dataset for evaluating cross-lingual question answering performance. The second one is tie-dye QA, typologically diverse question answering. This is mainly a question answering dataset covering 11 typologically diverse language with 200k question answer pairs. The third one is MLQA, multilingual question answering, is a benchmark dataset for evaluating cross-lingual question answering performance. There are different sizes of mT5 model. Actually, you can see in this graph, there are 5 types of mT5 model: mT5 small, base, large, XL, double XL. And they are categorized by the number of parameters. The mT5 small contain 300 million parameters, whereas the mT5 double XL contain 13 billion parameters. Now moving on to the fine-tuning in mT5 model. The mT5 model is fine-tuned using 3 different techniques. The first one is zero shot. And this model is fine-tuned only in English data, and then it is evaluated on task and multiple language without any additional training. This approach tests actually the model's generalizability to new language without any explicit training. The second one is translate train. This is basically the model is fine-tuned in English data, then additional data is added through machine translation into each of the target languages. The third one is in-language multitask. This is basically trained on goal data in all target languages. The results have been evaluated by the author of this paper that the mT5 XXL exceeds state-of-the-art on all classification and question answering tasks. And the scaling up simple pre-training recipe can be a viable alternative to more complex technique. In translate train setting, they have exceeded the state of the art on all extreme classification and question answering tasks. After that, they can say that mT5 model is highly effective for cross-lingual transfer learning, and its performance can be further improved by fine-tuning on data in multiple languages or through machine translation. You can see in this table the fine-tuning results. There are three settings: cross-lingual zero-shot transfer, which is mainly fine-tuned on English data. Here, mT5 XXL exceeds their performance or their accuracy result than all other accuracy results in the category of sentence pair and question answering pair. But the Rimbert got the highest accuracy in wiki and NER, where it is 70.1, but mT5 XXL closely got the accuracy result of Rimbert. The second setting is translate train model. This model fine-tuned on English data plus translate train in all target languages. They haven't evaluated any wiki and NER task, but in the remaining tasks, which is sentence pair and question answering, they mT5 XXL got the highest accuracy than all other models. Same thing happens in the last settings in language multitask. Here they have done only one evaluation, which is called wiki and NER, and here the mT5 XXL got the highest accuracy, which is 92.2. Next, the comparison. Actually, the comparison mainly the T5 comparison is done by the squad reading comprehension benchmark between the T5 and mT5 model, and the small and base mT5 model performed worse than English T5, but larger model closed the gap. You can see in this table that T5 model got the highest accuracy than mT5 model, but the XXL model got the almost same accuracy like T5. But if you think about the capacity of T5 and mT5 model, there is a huge difference between them in terms of dataset, because T5 model can able to perform only in English language, because this model trained only in English language. On the other hand, mT5 model can able to perform 101 languages. So you can imagine the generalized capacity or capability or robustness of mT5 model. Now moving on to the evaluation are run using large model as baseline. They have increased the dropout to 0.1 to mitigate overfeeding on low resource languages, decrease the sequence length to 512 as like the T5 done, and increase the average noise span length in pre-training objective to 10 to account for fewer characters per token than T5. After that, they have adjusted the language sampling exponent, which is A to 0.2 or 0.7 as used in MM, NN, MT, and MBERT respectively. They have turned off the line length filter in MC4 data pipeline. After that, they have supplemented MC4 with Wikipedia data from 103 languages. In each case, average XNLI score is lower than the MT5 large baseline, and they have justified the chosen setting was really appropriate for this research study. Now moving on to the ablation, you can see in these table that the baseline model, which is mT5 large, got the accuracy 81.1, and if they have applied the dropout during pre-training, the accuracy is decreased, and this is 77.6. After that, the sequence length, which is 512, where the accuracy is decreasing, and the same thing happened in the remaining part. Now moving on to the zero shot generation. In the zero shot generation, mT5 can generate arbitrary prediction, unlike encoder-only models, which can only extract a part of input or can predict a class. It also creates the problem, which is trouble zero shot generalization. Explanation of mT5 is having trouble generating a well-formed prediction in language other than the language in which it was fine-tuned, maybe due to less constraints during prediction. In X-squared zero shot, most of the errors due to accidental translation to English. There are some illegal prediction occurs by mT5 model, like normalization, grammatical adjustment, accidental translation. You can see in this table, in the last row, there is a 12-point superscript A in the target language, but mT5 prediction is 12.A, where superscript is missing. This type of illegal prediction have occurred by mT5 model, and this type is called normalization, and this legal span may be recovered through Unicode and FKC normalization. You can see in these target states, and there is a little bit morphological changes to the original state. So the last one, you can see in these target sentence, there's a Chinese sentence, and in the prediction, before beginning of the Chinese sentence, there's an English word which is new and ended up with Chinese sentences. It was kind of unexpected. And this kind of illegal prediction is called accidental translation, and it occurs when a model generates translation that are valid in another language but not in the intended target language due to the shared parameterization across multiple language. And the author of this paper addressed some solution for accidental translation. They have performed a task-specific fine-tuning mechanism, which is commonly done in encoder-only models. There are also some drawbacks. This is against the general text-to-text inference, as it requires different inference for different tasks. It won't be applicable for more open-ended zero-shot generative tasks like summarization. There are some other solutions the author of this paper proposed for reduce the accidental translation. The model forgetting other language due to the fine-tuning in English, so prevent from forgetting. The solution is that they have mixed a bit of unsupervised multilingual pre-training data along with the English fine-tuning data. And the steps are remove all sentinel tokens from the target sequence. They have reduced the language sampling parameter from 0.3 to 0.1 to get all language with nearly equal probability. The results they got that they can reduce the illegal prediction rates by more than 70%, and they have contributes to overall error reduction. Actually, in this paper, the major three contribution have given by the authors of this paper. The first one is they have introduced mT5 and MC4, the multilingual variant of T5 and C4 dataset. And they have demonstrated the applicability of T5 recipe to multilingual data directly. And they have done the zero-shot evaluation and proposed some solution for the issue. And there are some limitation of mT5 model, and some other authors have proposed some technique. First one is NMT5. They have added parallel data to mT5 pre-training and improved zero-shot cross-lingual task. The second one is switch transformer. They have added sparse parameter to T5 and mT5, where they have improved pre-training and inference speed. The last one is by T5, where they have outperformed mT5 on noisy text and transliteration tasks. That's all for mT5 model. Thank you.